the homework for the remainder. Okay, so in the expression of 3 rad 5, the number 5 is called, I actually gave you this 2 seconds before you took this test.
I got that one right in the slide.
That's a good thing you were listening, Brad.
I was.
Okay, so I know that 3 is the index, and somebody rewrote it, and I kind of had to think about this because I think I gave that person partial credit. The person wrote this as 5. In this scenario, what would 5 be?
The base.
The base. Okay, in this scenario, that would be the base. This is the exponent. But in this, if it's written like this, it would be the radicand. Okay, so you just need to be careful with that vocab. Okay, so number 6. Let me see. My work, pardon me?
What about number 2?
Haven't gotten there yet.
Why'd you go from 1 to 6?
You just said number 6.
Oh, sorry. Got it. Sorry, I don't know what I was thinking.
Well, no, you can't leave it at 24.
All right. So, I don't know what I was thinking. I know what I was thinking. I don't know why the number 6 came out. I was thinking, this is very sloppy, and I don't do them sloppily when I'm going to show them to you, so please bear with me. Okay. So I know that when y varies inversely, and immediately I know I have an inverse variation. It's going to be y equals k over x. So when this was their plug and chug, when y equals 6, plugged it in, and when x is 10, find the constant of variation. So you had to find k in order to solve this. So when k was, k is going to be what? 60? And I'm going to find it when find y when x is 15. Let me see, 60 divided by 15 would give me a 4. Okay, we good with that? Yes.
Yeah, I go to the bathroom since I get this.
Okay. Okay, number 3. I asked you to graph and label each curve. Okay, x to the 3rd we know has this shape. Okay, and it was y to the negative 4, so if it's an even number, it has to be facing down. And I know that it's going to go through what points, by the way? There's certain points that it should go through.
1, negative 1, 0.
1, negative 1, 0. Okay, so I should be able to plot those points and see where they're going to go through. Okay, you had calculators. I didn't say don't even look at your calculators. If you didn't know it, you could have graphed it. Okay? All right, number 4. All right. You're going to need to know this for this lesson coming up. And at this point, the rules for, we have 3 or 4 rules that we need to know. When we're multiplying exponents, what are we doing to the exponents? Adding them. Okay? When we are dividing exponents, we are subtracting the exponents. And what happens when we're raising an exponent to a power? We're multiplying them. Okay, so several of you still are a little confused. So I have x to the 2nd, x to the negative 1. I'm multiplying, so I'm adding. Negative 2 plus 1 is a 1. Y to the negative 4th, and y, there was no number there, but I know if there isn't an exponent, the exponent is what? 1. So y to the negative 4th, y to the 1 is y to the negative 3. Z to the 1, z to the 8th is z to the 9th. But the directions were to write it as a positive exponent. I know a negative exponent is telling me that I have a small number and I can just move it down, so that would be y to the 3rd. Okay? Everybody okay with that? Okay, and then I'm multiplying, so 3 times 5 is 15. All right, simplify and write in scientific notation. Scientific notation, I know that the decimal can't be in front of the number, it has to be to the right. So if you left it like that, I took points off. Now, I know I'm dividing here, so I have 3.6 divided by 9 was my 0.4. 10 to the 18th divided by -5, what am I doing? I'm subtracting. So what is minus a -5? So this is saying 18 minus a -5, and it's going to become plus. So I have 10 to the 23rd. Now this is when I have to think, is this going to be a big number? 10 to the 23rd. I'm gonna have to move those zeros a bunch of places. Okay? So, but this isn't in scientific notation, so I have to move it over here. Do I still have to move it 23 places, or have I already moved it once? I moved it once, so it's no longer 23 places to get to the end of the number, it is only 22. You really have to think about what kind of a number do you have. It's going to be a big number, you're going to, and you've moved it one place, well, then you have one less place to move. Okay? Anybody have any questions on that? Okay. I understand that a lot of people had problems with this. I thought that's why I could give you, I told you what illuminance stood for. And if you had this basic idea, I think I gave you quite a few points for just setting up the equation. And the illuminance E varies directly with intensity and inversely with the square. Some of you forgot that it was square, so you had to square that, okay? So you are now looking at 72 is equal to K over 200, K times 200 over 100, and I had to find what? My constant. Well, once I knew that the constant was 36, it was a matter of plugging it in, and the aluminums would have been 36 times 250 over 15 squared, and the answer was 40 units. Okay? All right, so that one I know was a challenge for some of you. Okay, let's look at this one. Simplify the expression. Am I taking an exponent and raising it to a power? Okay, when I raise to a power, what do? Multiply. So 2 times 3 is 6, 5 times 4 is 20. Can I simplify 6/20ths? Is 3/10. Okay? So far, so good? All right. I changed the problem that I had on this test and I gave you this one. At first I thought, wow, this is a really easy problem. I'm giving them an easy problem. Okay, so what am I solving for? R. What do I have to get by itself? So I'm going to divide 4 pi. Okay, can I simplify s over 4 pi? No. But I now have s over 4 pi is equal to r squared. Do I want r squared if I'm solving for r? No, I need to take the square root. If you left your answer like that, that was fine. Could I have simplified this further? What is the square root of 4? Since this is multiplication, can I pull that apart? And I could have said 1/2 s times over pi is equal to r. So I accepted, if you left the 4 in, I accepted that. If you took the 4 out and told me that it was a square root, what?
Wouldn't it be 2? Right?
It's in the denominator,
Oh.
right?
Yeah.
Okay, so you can't just pop it up,
Yeah.
okay? Okay? All right, and then what was the question? So the surface area of Io is about 4 times, 4.16 times 10 to the 7th. What is the radius? And this was a matter of what? Plug and chug? Hold on a second, let me see where I did the work on this. I don't have the work, but we can figure this out. So the surface area, so if I have, what are they giving me? The surface area is here, and what is the radius? Since I have radius by itself, and so let's go with this, it doesn't matter what you've used. So if I know that the surface area is 4.16 times 10 to the 7th, and it's being divided by 4 pi, I'm going to take the square root, and that will give me the radius. Yes? Okay, so, I mean, you could have done this a couple of different ways. What is 4 times pi?
About 12.56.
Is 4, 5, 12.56. Two ways to have done this. Could I have said 4.16 times 10 to the 7th? And could I have written it, is this in scientific notation right now?
No.
No, I could have written it. Now think about it. This is the number. Okay, if I move the decimal over one place, what will this have to be?
1.
1. So I could have said 1.256 times 10 to the 1st. You could have done that. And then, wouldn't this have been an easy division? Okay, you could have done it that way. You could have just said 12.56 and did this huge number and taken the square root. And there are a couple of different ways to have solved it at this point. And the answer was 19.918, blah, blah, blah. Oh, I did it that way. I just found it, sorry. I had it right here. So I just did what I just showed you here, and I divided this out, got 3.31, blah, 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 and took the square root, and my answer was 1819.91, blah, blah, blah.